Right, today we're going to look at extending our trig ratios to include angles not only in a right angle triangle, but angles from 0 to 360 degrees. So we're going to work on a Cartesian plane. All trig angles start here on the x-axis. This is 0 degrees. And then this would be 90, 180, 270, and then finally a full revolution would be 360. So if you can imagine that all trig angles start there on that axis, and as I move anti-clockwise, so you can imagine there are two lines on top of each other here, I'm going to move the one away from the other, and it's going to make me an angle of theta. Okay, so this angle, this line here, we call the terminal arm of the angle. It starts on the x-axis. This is the terminal arm. Okay, so we use a circle to follow the 360 degrees round, but we're stopping at different points along the circle. So for this angle theta, it would have an x and a y coordinate on the end of the terminal arm there. Okay, and then this terminal arm we call r for radius, because you can see that it's the radius of this circle that we're going to be working around. All right, so this angle we could make it into a little right angle triangle, and the side here, this would be the y, because that would be the length of the y coordinate. On this side here would be the x, because that would be the length of the x coordinate. And then this side here would be the r, or the hypotenuse. You can see that it would be the hypotenuse of that right angle triangle. So what we do is we extend our SOHCAHTOA to be able to use the x, the y, and the r. And I don't know if you can see that for theta, the y would be the opposite. Okay, so this would be the opposite. The x would be the adjacent. And the r would be the hypotenuse. So I could still use opposite, adjacent, and hypotenuse, but when I go onto Cartesian plane, it's better to change it into x, y, and r. So sine of theta, which is normally opposite over hypotenuse, would be y over r, because y is the opposite and r is the hypotenuse. Cos of theta, which is normally a over h, is going to end up being x, which is the adjacent side, over r, and tan, which is normally o over a, is going to end up being opposite y over adjacent x. So when we work on a Cartesian plane, instead of using SOHCAHTOA, we use sine is y over r, cos is x over r, and tan is y over x. And this little mnemonic, save your rear, sine is y over r, okay, cos x rays, so cos is x over r, tan your exterior. I know that's not how you spell exterior, but we're going to, so tan is y over r. So that little mnemonic enables you to write down your ratios in terms of x, y, and r instead of SOHCAHTOA, opposite, adjacent, and hypotenuse. Okay, so if we thought about an angle, because I was saying just now that we could work anywhere around this circle. So say I wanted to have an angle here. Oopsie, sorry. Let's do it on this one. Okay, so say I started on, there's my arms on top of each other, and the one arm moves away from the other one, and I end up here in the second quadrant. Okay, so we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So I've made an angle here, an obtuse angle of theta, and this one here is a terminal arm. So this arm will have an x and a y coordinate for that point that it stops, and it's going to have an r, a radius, the length of the terminal arm. Okay, and you could do that in any quadrant. Let's just go into the next page. So again, imagine both the arms are starting here. The one moves away from the other one, and it moves round. Say it stops in this quadrant. There's my terminal arm. So my arms have moved that distance, so that's my angle. And again, this gives you your r, and then your terminal arm has an x and a y coordinate where it finishes. Okay, so if we look at our quadrants, we said that this was 0, 90, 180, 270, and 360. In the first quadrant, your x, remember this is x and this is y. Okay, so your x here would be positive. Your y would also have a positive value, and your radius of your circle always has to be positive. You can't have a negative radius. In the second quadrant, here my x would be a negative. These are all negative x's on this side here. So this would be a negative x. Just take the equals away. So x is negative. Y is going to end up being positive. These are positive y's, and r is always positive. On the fourth quadrant, if your angle is between 180 and 270, it's a reflex angle there. Your x is still negative. These are negative x's. Your y is also negative. These are negative y's below 0, and r again always positive. And in the fourth quadrant, x is going back to being positive here. These are positive y's. Sorry, positive x's. Y is negative and r is positive. So if I look at the trig ratios, save your rear, cos x rays, tan your exterior. For each quadrant, your signs on your x, y, and r are going to be changing. So let's do this again. 0, 90, 180, 270, 360. So in quadrant 1, we've got x, y, and r that are positive. So sine in quadrant 1 would be y positive over a positive for y over r, which would give you a positive. Cos, again, x is positive, r is positive, gives you a positive, and tan, x and y both positive, so it gives you a positive. So in quadrant 1, all the ratios are positive. Right. In quadrant 2, we can see above here, we said x was positive, negative, y was positive, and r was positive. So if I look at my trig ratios here, sine is y over r, so it's going to be positive over a positive, which gives me a positive. Cos is x over r, so it's a negative over a positive. It's going to be negative. Tan, y over x, y is positive, x is negative, which is going to give me a negative. So in the second quadrant, only sine would be positive, the other two ratios would have to be negative. So in the second quadrant, sine is positive, the others are negative. Okay, if we look at the third quadrant, sine y over r, we said in the third quadrant y was negative, r is positive, which makes sine negative. Cos x negative over r positive, negative. And finally tan is y, which is negative, over x, which is negative, which gives me a positive. So now in this quadrant, sine and cos are negative and tan is positive. So this quadrant, quadrant 3, tan is positive, others are negative. Okay, and then finally looking at quadrant 4, if your angle is between 270 and 360, sine y negative over r positive gives me a negative. Cos x over r, x is positive, r is positive, so that's positive. And tan y, which is negative, over x, which is positive, which gives me a negative. So in the fourth quadrant, cos is positive and the others are negative. Now this diagram that we've just drawn up and I've scribbled all over is called a cos diagram, and we need to learn in which quadrants the angles are positive and in which quadrants the functions are going to be negative. So what we do is, when we think of trig that works on a Cartesian plane, we draw ourselves this cos diagram and we put in the north 90, 180, 270 and 360, and from the previous page we saw that all the ratios were positive in the first quadrant. So this is quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Okay, so they were all positive in the first quadrant. In the second quadrant here, only sine was positive. So that's what we're going to write there. Sine is positive, and because we've written sine there, we know that that's a positive one, and the others, cos and tan, are the negative ones in that quadrant. Okay, what happened in the third quadrant? Tan was the only positive one. Sine and cos were negative, so here I write tan. That's the only positive one there. Sine and cos are negative. And in the fourth quadrant, looking back here, cos was the only positive ratio. The other two were negative. So in this one, we're going to write cos. Okay, and this CAST, that's why we call it a cos diagram. So, okay. You can also remember that if you want to start from quadrant 1, you could do all students take care. So that's A, S, T, C. All right, all students take care, or sometimes it's just easier to remember cast, but remember then you're starting in quadrant 4 and you're writing C-A-S-T, cos, all, sine, and tan. So that tells me which quadrants the ratios are positive in. So if I said to you, if cos theta was negative, so smaller than naught, and tan theta was greater than naught, in other words, positive, which quadrant would I be working in? Okay, so cos is negative, tan is positive. Well, we've got two quadrants where tan is positive, because our diagram tells us where the things are positive. So that could be quadrant 1, because they're all positive in the quadrant 1, and quadrant 3, because tan is positive in quadrant 3. Now I need to check between these two quadrants, where is cos negative? Well, in quadrant 1, cos is positive because all the ratios are positive in the first quadrant. So this is where cos is negative. Therefore, I'm in the third quadrant. Okay, so this is just teaching us to move around this diagram. Okay, quickly again. All sin, tan, costing. Okay, so there's our very quick cos diagram. Okay, so this is quadrant 1, 2, 3, and 4. Okay, so let's try another one. Where does the terminal arm lie? Sorry. Where does the terminal arm of theta lie? If, let's do cos positive and sine negative. Okay, so cos must be bigger than naught, positive, and sine theta smaller than naught, that means that's negative. So again, we're going to start with the positive because this diagram shows me where the angles are positive. So cos is positive in quadrant 1 and in quadrant 4. So all positive in quadrant 1, only cos positive in quadrant 4. So that's the two quadrants where cos is positive. So of these two, where is sine negative? Well, let's check. Can't be in quadrant 1 because sine's positive there. In quadrant 4, only cos is positive. So sine is going to be negative in quadrant 4. So the terminal arm is going to lie in quadrant 4. Which means that if we were drawing this angle, it would start there and it would stop there in quadrant 4. That is what my angle would look like. That would be a quadrant 4 angle. All right, let's try one more. Where does the terminal arm of theta lie? If sine is negative and theta lies between 90 and 270. Okay, so this one is slightly different to the one we did before. Here we're going to have to first decide which quadrants I could be working in. So if you look that theta has to lie between 90 and 270, okay, the 90 and 270, that would mean that it would have to be either in quadrant 2 or quadrant 3, because that's 90 to 270. Okay, so this would be 2 or 3. All right, now this piece of information now tells us sine is negative. Now in quadrant 2, sine is positive. It says there, quadrant 2, sine is positive. So this tells me I must be working in quadrant 3. So that answer to this question would be quadrant 3. Okay, so we've just basically been looking at where terminal arms lie given the signs of the ratios. And I'd like you to try some of those before we move on.